Hello everyone, welcome to the next session of Unit 4. In this session, we are going to talk about UV VL spectrometer. If you can just recall, in our previous session, we had a discussion on absorption spectrum and Beer-Lambert's law. Absorption, whenever any wavelength of light passes through a particular object, a liquid, a solution, certain amount of it is absorbed and certain amount of it is emitted. In this UV spectrometer photometer, similar principle is applied. But what is more specific is, here we are using two ranges of light. One is UV, that is ultraviolet, and visual light or visible light. So two different spectra of light are used to measure the concentration of the given sample. Okay, so this is actually an analytical technique which will measure the amount of discrete wavelength of UV or visible light that are absorbed or transmitted through a sample, and here you are comparing it, simultaneously you are comparing it with the reference blank sample. Okay, so that means you need two things. One, you need a blank sample, the other one is the solution of your interest, the sample of your interest. Principle is same. You are passing the light of certain wavelength through a solution or a sample. Okay, we are already aware that some amount of it is going to be absorbed and some amount of it is going to be transmitted. You are going to see how much amount of it is absorbed or transmitted by using a detector. Then you are comparing it with another blank sample so that you can compare and you know what has been absorbed and what has been emitted. You need a reference. So here this is the construction, a simplified schematic representation of the UV VL spectrophotometer. There will be a light source. This can be a UV or a VL. So, two different sources of light are going to be used. Then you will have a wavelength selector, okay, based on which you are going to select the wavelength of light you want to check on, and that depends upon the color of your sample. You have to use a wavelength of light that has a compatible molar absorption coefficients, the epsilon. Okay, so selection will be depending upon the sample you are going to get analyzed. Then there is a sample loader, a cuvette is used. When you select a wavelength of light, the light is going to be passed through that filter, and then only the selected wavelength of light will be passing through the sample. Okay, and here at the same time you are going to use two things. One will be the sample itself of your interest. The next one you will also use the blank. So what happens? The selected wavelength of light will fall on both blank as well as on the something that is of interest. So let's say this is blank and this is the sample you want to test. Simultaneously with the same intensity of I0, it is going to fall on this solution, both blank and on the sample. Then based on the species that are present, the constituents of this blank and the sample, certain amount of it will be absorbed, certain amount of it will be transmitted. And in the next step, what you are doing, you are going to use the detector. Okay, so this detector will detect the amount of light that has been passed. There will be settings for absorbance and the transmittance. You can select any one of them. So this will detect the amount of the intensity of the light that is transmitted for blank as well as for the sample. Then it will compare, and based on that, this information will be fed to a processing unit, and then it will be output in the form of usually the wavelength of light. So in the form of wavelengths. okay, or it will give you a graphical format, in the graphical format. Okay, so this is the simple construction of a UV visual spectrophotometer, and here based on the type of chemical you are analyzing, you can select UV or visual. Now for the light source, usually a xenon lamp is used, okay, because high intensity light sources you can get for both UV and visible ranges. In certain cases, there might be two different lamps, a tungsten or a halogen lamp. It is used for visible light, and a deuterium lamp is used for UV light. So either you can use a xenon lamp, which can give you the light in both the ranges, both UV and the visible light, or there might be instruments which use two lamp systems or light sources. In such cases, tungsten and halogen lamp or halogen lamp is used as a source of visible light, and deuterium lamp is used as a UV light, source of UV light. Okay, and there are also, see, the second component is the wavelength selection there. Here too, depending upon your necessities, you are going to use different wavelength selection devices or units. So there are monochromators, there are absorption filters, there are also interference filters, cutoff filters, and bandpass filters. These are all different filters that are used to select any wavelength of your choice. Your wavelength of choice will depend on the type of chemical you are going to analyze. Because if the chemical has a yellow color, then you'll have to use a suitable wavelength of light, so that there is a maximum absorption and emission. If you are going to check the transmission, then the wavelength should be the opposite of it, the wavelength you have selected. Okay, so wavelength selection depends on the color of your sample to be tested. And sample analysis is done by using a cuvette, which is usually formed of a quartz, because the cuvette in which you have kept the sample should not be absorbing. So it should not absorb the wavelength which you are using. Because if your sample holder is absorbing a certain wavelength of light, then you won't be able to actually analyze the concentration of your sample. That's why the sample holder, its nature should be in such a way that it is totally transparent to the wavelength of light you have selected. So that's why quartz is something that is used in UV spectrophotometers, because it is transparent. Okay, nowadays even cuvette free systems are available that helps in analysis of even very smallest amount of sample volumes like DNA and RNAs. And for detection, so once the transmission has taken place, they will be detected by using photoelectric coatings or semiconductors. The detector, which contains a photoelectric coating or a semiconductor, will detect the emitted light, and then it will be passed on to a monitor where it is given in the form of the waves, or a graphical representation is given. Now, what's the strength of this UV-VS spectroscopy? So, it is non-destructive. That means once a wavelength passes through the chemical, it won't destroy the nature of the sample. The same sample can be then used for further analysis. So, it is non-destructive, and measurements are very quickly done. So easily you can integrate the experimental protocols. It is non-destructive, it is quick, and it is easy to use. You are only supposed to load your sample, and there are settings, you just switch it on and your readings will be available. Data analysis is also, it requires minimum processing because as soon as the detection is done, there will be display of your result. So analysis, it is not tiresome, so easily you can get the report, and that means minimum training, just operating if you know, then easily you can get the results. Inexpensive in the sense, once you have installed, the site charges are very less, so it is comparatively affordable, so most of the laboratories make use of it. Now coming to the application of this, it can be applied sample analysis, because it is an analytical technique to know the concentration of any chemical of your interest. You can use this one. Here major analysis is of DNA and RNA, and even pharmaceutical analysis, trying to find out the concentration of any drug of your interest. It is also used in bacterial culture to know the concentration, to know the bacterial growth. Okay, there are scintillation counters also. They are also used for bacterial culture, and even beverage analysis. So chemical analysis to know the purity of the chemicals, or to know the concentration of the chemicals. You can make use of absorption, UV and visual spectroscopy. So these are all my references. Thank you for your time.